Welcome to CodingCraft. In this episode, we'll solve another real meta coding puzzle, Rotary lock. In level 1, we'll calculate the shortest time to enter a sequence using a single rotating wheel. In level 2, the challenge increases. We have 2 wheels, and we must decide dynamically which to use for each step. Let's break it down step by step. This is the level 1 version of the Rotary lock puzzle. We're working with a single wheel labeled from 1 to n in a circle, starting at position 1. For each number in the code, we rotate to it in the shortest direction, clockwise or counterclockwise, with each move costing 1 second. The goal is to enter the full sequence as fast as possible. In level 1, we have up to 50 million positions on the wheel and up to 1,000 code digits. Since we only move from one number to the next, we can solve this efficiently by calculating the shortest circular distance at each step, either clockwise or counterclockwise, using the formula, minimum of absolute difference and its complement. Here's the code for level 1. We use a helper function to compute the shortest distance on a circular lock between 2 numbers, either directly or by wrapping around. Starting at position 1, we loop through each number in the code and add the shortest rotation time step by step. Level 2 introduces a twist. We now have 2 wheels, both starting at position 1. For each number in the code, we can choose which wheel to use. Each wheel moves independently, and we still want to enter the full code in the least amount of time. The constraints are larger, so we'll need a smarter solution. In level 2, we deal with much larger constraints and a new decision layer. We now have 2 wheels, and for each number in the code, we must choose which wheel to move. Each wheel starts at 1 and moves independently. Our goal is to minimize total time by selecting the cheaper option at each step, either with a greedy or optimized strategy. To solve level 2 efficiently, we use a dynamic programming approach. We track all possible positions of both wheels, and at each step, simulate 2 choices, move the left wheel or move the right wheel. We update our state space with the minimum time for each position combination, and at the end, return the smallest value. This allows us to make the best wheel choice at every step without redundant calculations. That wraps up Meta's Rotary lock puzzle. From a simple circular wheel strategy in level 1 to a dynamic programming approach in level 2. If you found this helpful, don't forget to subscribe to CodingCraft for more interview-level puzzles and clean code solutions.